What's up, Tumnad Lectures? In this video, we're going to talk about glomerular filtration, okay? And we really need to first understand what glomerular filtration is, okay? Glomerular filtration, this is the process through which the blood plasma passes through what we call the glomerular capillaries into what we call the Bowman's space. That is the real definition of what we call glomerular filtration, a process through which the blood plasma passes through the glomerular capillaries into the Bowman space. As simple as that. But now we really first want to understand the really anatomy of what we call the renal corpuscle, because the process of glomerular filtration is going to be taking place in what we call the renal corpuscle. What's the renal corpuscle? The renal corpuscle is a combination of what we call the glomerulus and then the Bowman's capsule. So now when you see this whole structure here, where we are having the loops of the glomerulus capillaries, and then with this sac-like structure, what you're calling the Bowman's capsule, the whole of this one here is what we call the renal corpuscle. One more time, renal corpuscle. This is a combination of what we call the glomerulus and then the Bowman's capsule, okay? So now we need to first understand what is made, or we need to first understand what is exactly contained in what we call the renal corpuscle, okay? Now, when you see these kind of loops, they are what we call the glomerular capillary tufts. Okay, they are what we call the glomerular capillary tufts. They are wound in this inside space. Okay, but now when you see there is this thin like black layer, this kind of membrane which is now moving like this, how do we call that? That membrane is what we call the glomerular basement membrane, okay? That black layer which you're going to be seeing, it is very, very, very important, okay? Now, when you see on these capillaries which are very close to what we call the glomerular basement membrane, they are going to be having some kind of endothelial cells. We shall zoom in and see exactly the type of these endothelial cells and what they contain, okay? But again, on the glomerular basement membrane, below it, we have these food process-like cells, okay? How do we call these kind of green cells? These green cells, they are what we call the podocytes. They are what we call the podocytes, okay? The podocytes, they have food processes that are anchoring on what we call the glomerular basement membrane, okay? But now, the podocytes, these podocytes, there is a space in between them. Okay, there is a space in between them. When you see this space from one podocyte to another, how do we call that space? That space is what we call filtration slit. Okay, this space here, this space you are seeing here, this space here is what we call filtration, slit. Okay, filtration slit. Now again, between one podocyte to another, we have these kind of structures that are like sticking together, these podocytes together on their membrane like this. Okay, these kind of structures that are in between there, how do we call these structures? These structures like this one here, they are what we call slit. They are what we call slit diaphragm. They are what we call slit diaphragm. And primarily this slit diaphragm, they are made up of proteins like nephrin. They are made up of proteins like nephrin. They are made up of proteins like podocins. Primarily, those are kind of proteins that make up this kind of what we call the slit diaphragm. Okay. So now we want to first now cut the whole of this area here. We want to first cut the whole of this area here, and then we zoom it and see exactly how it is going to be arranged. Okay, so now we have brought this point here, we have cut the whole of this point and we have brought it here. We want to see exactly what is made up of what we call the glomerular basement membrane and what are some of the structures that are near the glomerular basement membrane. Okay, now when you see the whole of this structure here, this is what we call the glomerular basement membrane, the whole of this structure here. But again, above the glomerular basement membrane, we have this capillary. We have this capillary with these endothelial cells, okay? These endothelial cells that are lining the inner lining of this capillary. Now, we were going to extract a single endothelial cell and look at it critically and see what is going to be containing. So now, this is now one of the endothelial cells that has been extracted on the inner wall of what we call these capillaries. Now, when you zoom it very well, we are going to be having these kind of holes. It's going to be having a lot thousands of holes, okay? How do we call these holes? These holes you are seeing, they are the one we call fenestrations. They are what we call fenestrations. Fenestrations are very, very important in the way that they are going to be allowing certain kind of electrolytes, certain kind of molecules to pass through to come and reach what we call the glomerular basement membrane, and of which eventually will move out into what we call the Bowman space. Okay? Now, these fenestrations, they are very, very, very many, and this is the reason why the kidneys contain what we call fenestrated type of capillaries. Okay? Now, how big are these holes? What is the real size of these holes? These holes, they are approximately between 70 to 100 nanometers, okay? But again, you will find some other sources whereby they are going to be telling you around 60 to 80 nanometers, okay? There are some other sources that are going to be giving you that range, so you should not be hesitant on these ranges of what we call the size of the fenestrations, okay? So now, coming back on this glomerular basement membrane, when you examine very well the glomerular basement membrane, you're going to be finding a very dense, thick area in the center of this glomerular basement membrane, okay? So now you're going to be finding this dark area in the center of the glomerular basement membrane. This number 2, how do we call it? They call this one as lamina densa. Okay, it is called the lamina densa, and of course this glomerular basement membrane is going to be made up of what we call collagen type 4. And of course you need to be knowing that the different types of collagen, we have type 1, type 3, type 2, type 4, and there are very many. And of course type 1 collagen is found in the bones, and then type 2, they are found in the cartilage, and of course we are having type 4 found in what we call the glomerular basement membrane, okay? Now, we have some other light area on the glomerular basement membrane, the one which is next to the walls of what we call the glomerular capillaries, okay? This area which is now next to the walls of what we call the glomerular capillaries. How do we call this layer here, which is a bit light, translucent? This number 1. This number 1 is what we call lamina. Is what we call lamina rara interna. Okay, lamina rara interna. And then how about this translucent, which is exactly like the lamina rara interna, but this one which is now in the outside next to what we call the podocytes. How do we call this? This number 3. This number 3 is what we call lamina rara externa. Okay, lamina rara externa. So now these are the layers that make up the glomerular basement membrane. Okay, they are the layers that make up the glomerular basement membrane. So now we have said that these kind of structures that are holding the podocytes together, they are what we call the slit diaphragm, made up of proteins, nephrins, and what we call the podocytes. We have said that these are what we call the podocytes that make up you see this kind of layer of these podocytes, the whole of that layer is what we call the visceral layer. And of course now when you reach this area, now they start transition to another category of cells that are making up what we call the Bowman's capsule. How do we call this kind of layer of these cells here? This layer of these cells here is what we call the parietal is what we call the parietal layer. Okay, is what we call the parietal layer. Okay, so now these cells, they are making up what we call the visceral layer, and then these ones here, they are making what we call the parietal layer. They are very important. Okay, so now having looked at this glomerular basement membrane with these filtration slits, the slit diaphragm, seeing the fenestrations that are in what we call the endothelial cells of these capillaries. Now we want to see how is this glomerular basement membrane going to allow the different substances to pass through. And of course, they're going to be passing through following different types of pressures. Okay, we are going to look at what we call net filtration pressures, because it is this net filtration pressures that's going to start forcing different substances in what we call blood plasma. Okay, so we want to look at it, the net filtration pressure that's going to be forcing different components in what we call the blood plasma. Okay, so now that's what we call the net filtration forces. Now, coming on this structure here, we are going to be now seeing these kind of forces that are going to be pushing these components in what we call the blood plasma. So now, there is this kind of, whenever blood is coming, and then now we're going to be filtering the blood plasma, there is that kind of pressure, that is going to be pushing, the blood plasma from inside what we call the capillaries, the glomerular capillaries. Okay, this kind of pressure which is pushing out the blood plasma out into the Bowman's capsule. How do we call this type of pressure? This pressure is what we call the glomerular hydrostatic pressure. Glomerular hydrostatic pressure. And this glomerular hydrostatic pressure is approximately around 55. Millimeters of mercury. Okay? But again, there is going to be another pressure that is holding things not to leave the blood capillary. Okay? There is that kind of force which is going to be avoiding anything from leaving the blood vessel. Okay? And that kind of force which pulls the fluids back into the blood vessel. This kind of force which pulls things to come back. Okay? To push things to come back. That kind of pressure is what we call the glomerular oncotic pressure, or you may find people calling it the colloid osmotic pressures. Okay, so now the glomerular osmotic pressure on average is around 30 millimeters of mercury. Okay, now after we have collected now our glomerular filtrate, this filtrate is supposed to come and move down in this kind of segment, what we are calling the proximal convoluted tubule. But again, when this filtrate comes on this narrow proximal convoluted tubule, it is going to be getting a lot of forces to pass through what we call this narrow tubule, what we call the proximal convoluted tubule. There's that kind of force which is going to be generated here because of too much filtrate that is trying to pass through a narrow exit point, what we call the proximal convoluted tubule. Now, that kind of force which is going to be liberated there is going to be pushing things like outside the glomerular, outside what we call the Bowman's capsule. So now this pressure is going to be trying to push things outside what we call the Bowman's capsule. So now how do we call this type of pressures? This pressure is what we call the capsular hydrostatic pressure, and this pressure is approximately around 15 millimeters of mercury. Okay, now again there is going to be another pressure, but which is almost negligible, and that pressure is going to be like trying to retain things inside what we call the Bowman's capsule, and of course going to be exerted by what we call proteins. But of course we don't have proteins somewhere here in the Bowman space. If it is there, it is very small. So now there's going to be that very small, it is almost zero. But this pressure is supposed to be somewhere here. How do we call this pressure? This pressure is what we call capsular oncotic pressure. But this pressure is almost 0 millimeters of mercury. It does not account for any significant amount in a normal glomerular basement membrane. Okay, because it's supposed to be exerted by what we call the proteins, exactly like what we call the glomerular oncotic pressure, going to be exerted by what we call plasma proteins like albumin. Okay, now we are going to be getting now the net filtration pressure. How do we get the net filtration pressure? The net filtration pressure is going to be the glomerular hydrostatic pressure plus the capsular oncotic pressure, okay, then minus what we call the glomerular oncotic pressure plus what we call the capsular hydrostatic pressure. Okay, this is the equation of getting what we call the net filtration pressure. And we have said that the glomerular hydrostatic pressure is 55. And then the capsular osmotic pressure, we have said it is 0. Okay, then minus the glomerular oncotic pressure, we have said it is 30, plus the capsular hydrostatic pressure, we said that is 15. Okay, so now if you do the subtraction, that's going to be 55 minus 45, and this is going to give you approximately 10 millimeters of mercury. So now the 10 millimeters of mercury is what we call the net filtration pressure. This is the pressure that is going to be pushing different contents in what we call the blood plasma passing through what we call the glomerular capillaries. Okay? Now, when you increase the net filtration pressure, automatically you're going to be increasing the glomerular filtration rate. Okay? Anything that increases the net filtration pressure is going to be increasing the glomerular filtration rate. In other words, glomerular filtration rate is directly proportional to the net filtration pressure. Okay? Glomerular filtration rate is directly proportional to the net filtration pressure. Okay, but again, there are even very many other factors that can influence what we call the glomerular filtration pressure. What are some of the other factors that can influence the glomerular filtration pressure? We have said one of it is going to be now the net filtration pressure. Anything that increases it automatically increases the glomerular filtration pressure. Another thing is what we call surface area. Okay, is what we call surface area. So now with surface area, if you see this size of the glomerulus and you see this size of the glomerulus by surface area, where do you think you're going to be having a lot of glomerular filtration? We are going to be having a lot of glomerular filtration in this kind of glomerulus that has a wider surface area than this. So here we're going to be having low glomerular filtration rate, but again here you're going to be having slightly higher glomerular filtration rate just because the surface area is very big. Okay, then what else can affect the glomerular filtration rate? The permeability of these glomerular capillaries. If these capillaries are very, very, very much permeable, you expect the glomerular filtration to be high. Okay, so now also permeability. Okay, permeability of capillaries. Okay, permeability of what we call the glomerular capillaries also has a positive influence in increasing what we call the glomerular filtration rate. And we have said another one is the surface area of the glomerulus also influence what we call the glomerular filtration rate. Okay. Now, having looked at the net filtration pressure, we have seen now the force which is going to drive the blood plasma contents into the Bowman space. But now, let's have a look at what are those components that are really contained in the glomerular filtrate. Okay, what are these components that are going to be contained in what we call glomerular filtrate? We are going to be having electrolytes. We're going to be having electrolytes like sodium. You're going to be having electrolytes like chloride. You're going to be having electrolytes like potassium. You're going to be having electrolytes like magnesium. You're going to be having nutrients like glucose. Okay, glucose. You're going to be having contents like vitamins. You're going to be having nutrients like amino acids. Amino acids. We are going to be having contents like urea. You're going to be having contents like creatinine. You're going to be having contents like water. You're going to be having contents like water. You're going to be having contents like calcium. Calcium ions are going also to be there, and you're going to be having other contents like the lactate, and of course we are also going likely to be having contents like what we call some very small proteins. Some very small proteins, and primarily we have small proteins like for example insulin, and then also some small proteins like hemoglobin. Hemoglobin. Those are some of the small proteins that can maneuver around the glomerular basement membrane, and they find in what we call the glomerular filtrate. Okay. So the last one, which is very, very important. Um, do you all see these kind of cells that are going to be on the loops? They are going to be on the loops of what we call the glomerular capillaries. You see these kind of cells? Because the capillaries cannot just be, they cannot be just suspended in free space. There are certain kind of cells that are going to be helping in supporting what we call these loops of what we call the glomerular capillaries. How do we call these kind of cells? These cells are what we call mesangial, mesangial cells. Mesangial cells are super very important. Why am I saying this? Sometimes we may get some kind of complexes. We may find some kind of the immune complexes that want to come and start getting deposited in what we call the endothelial lining of these capillaries. So now these mesangial cells, they have the ability to start now attacking these complexes and phagocytose them. Okay, so now one of the role of these mesangial cells is phagocytosis of what we call the immune complexes that may want to come and start getting deposited around this kind of filtration area. And of course, when the immune complex bind there, they are going now to start the process of inflammation. At the end of it all, we're going to be having our glomerulus getting inflamed. And when it gets inflamed, of course, the permeability is going to increase, and of course, we're going to start allowing certain kind of cells like proteins, like red blood cells. They're going to start passing through, and someone is going to be having hematuria, is going to have proteinuria, a lot of that. So now, but how is this one protected? Because these mesangial cells, they are primarily there such that these immune complexes do not stick on this what we call the glomerular tufted capillaries. Okay. That's really a brief summary about glomerular filtration. Thank you very much for listening to me, and please, if you find this video has been helpful, it has added to you, please, the only way you can support me is by liking the video, sharing the video, and commenting down in the comment section. Thank you for listening to me, Tumunad, as always. Until we meet next time.